Morning, everybody. I think it's still morning. Greg Ella again, NØEMP. I'm your guest speaker today and talking about NVIS, Near Vertical Incidence Skywave. Our other member at large is working here. He's going to get some links up. I sent an email out to members the other day that had 3 internet links. Did anybody not get those? A couple people didn't. That's why we're going to get these up here in a minute. These are 3 good links for you guys to go to for further information on what I'm going to talk about. So I believe it's going to be posted on the club website as well, probably after this talk. I don't know if we can if we maximize that, I think we'll be good. Yeah, I don't know if we're going to be able to read that. I don't know if we can go full screen on that one page or not. There we go.
I put it on the website.
Yeah, well,
Still not changing.
yeah.
Format font.
Yeah, I had put it in a big font, but then it went from one type of system to another type of system and got emailed, and now it's gone to, I think I had it at 20, 22 would be good. There we go. There we go. So if you didn't get those links and you don't want to wait for them to be on the website, those are 3 good links for you to go to for further information on this. The middle link, or the top one, is the Boulder ionosound, which I'll be talking about here some more in a bit. That's the direct link to the Boulder ionosound, which when it's working updates every 5 minutes. The middle one is a gentleman that has a very good website with lots of cool stuff on it, including an NVIS section. And when you go to his NVIS, take note that there's 8 pages there. So when you get to the bottom, there's an arrow for the next page. He has 8 pages of stuff on NVIS that he talks about, and then he has more links on his web page. And the bottom thing is the good old Wikipedia article about NVIS, and that's a very succinct article as well, and it has some good links at the bottom. So those are the links you want to look for. How many folks in here are general or above, licensed general or above? How many technicians?
No.
Okay. And even the technicians, I know because I helped teach the last class, you guys learned some about ionospheric propagation, skywave, and talking over the horizon. If I could get the skip, there we go. So you put RF out kind of low towards the horizon. It will graze the ionosphere, and depending on what the ionosphere is doing and what frequency you're on, it'll bend back down to the Earth somewhere over the horizon, like so. The problem with this is it skips over an area. So in close, you'll have ground wave, and you'll be able to talk direct antenna to antenna via ground wave. Far out, you'll be able to talk to people, and they can talk to you over this ionospheric propagation, but there's a dead zone in the middle. This is before we even get into the issue of things like mountains, which we tend to have just west of here, which RF doesn't go through very far. So if you put an antenna up vertically, and we're going to talk about an HF antenna here. You put up an HF antenna vertically, either a big vertical dipole or something elevated with elevated radials, or something sitting on the ground with ground radials going out. Your RF is going to go up at an angle. It's not going to go straight up because of the ground. It is going to go up a bit, but it's going to go up at an angle. And it's going to encounter the ionosphere and do that. Ground wave, you can talk a few miles. I've had trouble on ground wave HF talking across Fort Collins. Talking from Fort Collins down to Broomfield, forget it. It's gone. Mike Ring a few years ago was doing a contest, or he was working for a Worked All States award, but it was a digital data mode, and it had to be on 20 meters. It was 20 meters only. And he worked all states except Wyoming. And he could not talk to Wyoming from Windsor And he was getting on the phone to hams in Wyoming. He was emailing the people over there to arrange schedules. He could not do it because of that. And he had to be on 20 meters. So he went up to my property, and we set up at 7,500 feet where you can see Wyoming, and we set up a vertical, and he was able to accomplish it from there by ground wave because you could see it, and we had a line of sight. So, vertical antenna is going to go out. Horizontal antenna, this is again HF, horizontal antenna, at least a half wave high or more, is also going to go out towards the horizon. It's going to go out off the sides of the dipole, and it's going to be pretty deaf off the ends. But on the sides, it's going to go out. It's not really going to go up. It's going to go out. And if you look at some of those resources, you'll see some neat diagrams and stuff. So the DXers, they typically don't put a dipole up because if they're going to go to all the trouble of getting up that high, they're going to put up a beam. But they're trying to put their RF out at the horizon. Well, that's great unless you're having some kind of emergency. I understand the folks in Norway are very nice people. They're probably not going to be a lot of help to you in Lermerwald County. So we want to talk in close. And again, that's before we get into the issue of mountains and canyons and things like that. This is just out in the open terrain. When you're trying to talk on the other side of a mountain or into a canyon or out of a canyon, there is no ground wave. So if you put your antenna lower to the ground, and all these heights I'm talking about are relative to wavelength. So if you're a quarter wavelength above the ground or lower, most of your RF's going to go straight up. And most of what you hear, including noise, is going to come from generally straight up, pretty much straight up. So it's going to put your RF up to the sky. You're not going to hear a lot of the noise you'd otherwise hear coming off from the sides. Depending on what frequency you're on and the time of day and what the ionosphere is doing, that RF that goes up is going to come back down in a fan area. Perfect. So we're not talking about a laser beam here where it's going to hit a pinpoint and come down at some pinpoint. It's more like taking a fire hose and pointing it straight up and having it rain down. And on HF, we're talking an area around 200, 300, 400 miles. Okay. And this will get in and out of canyons. It'll get from one side of a mountain to the other side. And even if we're out in the open, areas trying to talk from here to Denver or from here to Sterling, we won't have that skip zone. So what frequencies work for this? Typically, as a rule of thumb, which we'll expand on in a minute, 80 meters at night. Sometimes when propagation's really bad, you have to go down to 160. Very rarely, but that's at night. By 9, 10 o'clock in the morning, usually, one of the ionospheric layers called the D layer starts to build up. The D layer absorbs RF. It is not our friend. That's why late at night, if anyone's ever been out in the middle of Nevada or Utah, driving cross country at night, you can hear KOA from Denver, 8:50 a.m. on your car radio, because it does this. Come morning, it goes away. Even though they've actually increased power around sunrise, they can actually turn the power up. They're gone because that D layer absorbs that. Same with us, 80, and it absorbs the lower frequencies more. So 80 meters has been working through 8 a.m. because there's a net I'll tell you about. But by 9, 10 o'clock, Bob, it's going away usually, and that's D layer absorption. But at the same time, the upper ionosphere F layers are getting pumped up. We start to get 60 meters come in, which is 5.3 to 5.4 megahertz. And then we get 40 meters built in, 7 megahertz. 7 to 7.4 start to build in through the day. And then in the onset of sunset, that process reverses, so we lose 40 meters first, and then we lose 60 meters, and then we actually start to come back into 80 meters again. If I can get one of those pictures from the boulder I saw on either one. There's two. I took a couple screenshots. These are from the boulder ionosound, and like I said, when it's working, these things update, I think, every 5 minutes. They're very useful because this is in Boulder. It's close enough that this information is very relevant to us. There's a lot of information here that you don't need. There's a few things you do that I'll point out here. Because this ionosound sometimes goes offline, you want to check the date and the time. This day here is the day number. Julian date, is that what? So like January 1st is Julian day 1. January 31st is Julian day 31. March is like 90. So whatever this 3-digit number is, you don't care about it. Look at the date, look at the time, which is hours, hours, minutes, minutes, seconds, seconds. That's in Greenwich Mean Time. And we're now 6 hours behind them with the date, with the time change. So this screenshot was 12:005. So noon, Greenwich Mean Time. This was 6 a.m. here yesterday. And an ionosound, a vertical ionosound, which is what this is, does exactly what we want to do with NVIS. It has an antenna that shoots pulses of radar, HF radar, straight up. And it listens for echoes coming straight down. And it times that delay to figure out height of the ionospheric layer. It starts at 1 megahertz and sweeps up through 18 megahertz. So it plots the height of the reflective layer versus frequency. And at some point down here, it's not getting a return because of the D layer absorption. And at some point up here, it goes off the chart because the height of the reflecting layer, you're right at the top edge where you can work. And above that, it's not getting a return. There's 2 returns from the ionosphere, which gets into a bunch of physics that Terry Bullitt can talk to you about. But the green trace is called the ordinary or the O wave, and that's the strong return. There's another polarization that comes back that's about 25% of the strength of the ordinary wave. That's called the extraordinary or the X return. That's usually about 800 kilohertz higher, and it's about 1/4 as strong of a return. We've worked X return before, so we've worked in this region successfully, but it's not nearly as effective. When you're right in this zone where it's just doable, it's very fluttery, it's very in and out, lots of deep fading going on because this is a snapshot, but in reality this thing's moving. So you really want to be in this region before it really starts to go vertical. So anywhere in here. Within these ranges, right now, we've got 80 meters working just fine, 3.5, 4 megahertz, working just fine. We don't have 60 meters. We definitely don't have 40 meters. This is at 6 a.m. local time. Look at the other slide, Jim. This is next one's in the afternoon, a couple days ago, and it was typical of what we've been seeing lately. Here we've lost 80 meters. We're about to lose 60 meters due to D-layer absorption. But we've got 40 meters is solid, and this is nice and horizontal here. This is going to be a good reflector for us. We've got 10 megahertz, which is 30 meters. which we can typically use during the day, but that's digital and CW only. So no voice there, but this works on data modes as well. This has gone up to 12 megahertz. I've seen it go up to 13 in the last few weeks during the day. I haven't seen it hit 14, and I've never seen it hit 14. So there is no 20-meter NVIS. You'll see this stuff up here. This is a double return. RF went up, bounced down, went up, and down again. It didn't bounce off anything that's actually up at this height. This is the height scale here. It bounced off this layer twice, boom, 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 and made it, due to the time delay, made it look like there's something up here. So when you see this, it's a good indication that you have strong return from the ionosphere, but there's really not a thing up here. So you'll see here, MUF, maximum usable frequency. You'll see in some prediction or some propagation reports, you'll see MUF. You'll see in software like VOACAP, you'll see MUF. That's maximum usable frequency. That's not what we're using for NVIS. MUF depends on going off at an angle and glancing down and going over the horizon. And you'll see here, they have higher and higher frequencies of maximum usable frequency, or MUF, based on how far out you're going, which means how shallow an angle you're going out. So these are not actually measured by this ionosound. They take the ionospheric data and calculate these based on models, which turn to be pretty accurate because there's been 60 years of data to go on. So these are predictions for going out to distance. What we care about is this thing here, FOF2, which is the ordinary wave off the F2 layer. It's also called the critical frequency. So we care for NVIS about this top number. And again, we don't want to be right on that number. We want to be below it, down this curve a bit if we can be. Any questions so far on any of that? Roger.
Your vertical is kilometers?
Yeah, everything here is metric, kilometers, and megahertz, so yep. And if you want to get hyper technical, this height in kilometers is the apparent height based on RF going at the speed of light. In reality, when you get into the ionosphere, it's a plasma and RF slows down, which is why it refracts in the first place. And it's not like there's a solid layer that it just hits and bang, bounces back down. It goes in and it starts to slow down, it starts to curve, it starts to bend back down. So this is the apparent height, which is higher than the actual height because of this change in speed that they don't account for in this graph. Terry Bullitt, there's a presentation Terry Bullitt did, and it's on the NCARC website under resources, and he goes into all this physics. And some of these links I gave you to do as well, if you care to get into that. But the executive summary is there's this thing up above us called the ionosphere, and at the right time of day with the right antenna at the right frequency, it goes up and bounces back down and sprays the area. Mike.
What effect does the solar cycle have on this event?
Good question. What effect does the solar cycle have on this event? Everything. I have seen, gosh, I don't know, around December, January, there were times I woke up before sunrise and looked at this and it was blank. There was nothing there. Nothing. Maybe a little blip like here, which was just like some noise. It was gone like at 5 a.m. 80 meters had gone completely away. It hadn't started to build up the next day yet. It was gone. Now that we're getting into the solar cycle, or the top of the solar cycle, we're doing much better. But it has everything to do with the solar cycle. That's what drives the ionosphere. We had a... Yeah, okay, this is live right now. Right now, we've lost 40 meters. We've got 60. We've got 40. We've got 30 meters, barely. So that's right now. We had another question over here.
What is the maximum frequency that can be 20 meters is around 14 something.
Uh-huh.
Is it top out at around 20 meters or?
Okay, the question was, what's the highest frequency we can use here for NVIS? I've never seen it hit 20 meters. Right now, Jim just pulled this up, and this is live. We don't have a band at 13 megahertz. The military does, the government does, and using X mode, they could use 13 megahertz right now. That's about as high as I've seen. I've seen the O mode, this red, go to 13, and that's as high as I've seen it. Right now, we, on 30 meters, we could use 30 meters, but it would be sketchy because it's hitting this region that's really moving around. So
20 meters is,
there is no 20 meter NVIS.
or so like,
Right.
so you're telling me
Yeah.
like 40 meters, 7 megahertz and down.
Yeah, yeah. General rule of thumb, if you don't have access to this, say you're out and you've set up, or you're out and you have a problem, and you're up in the canyons or you're in the mountains and you have a problem, and you can't hit a repeater, and you want to try NVIS, and you don't have internet access to pull the stuff up, the general rule of thumb is 80 meters at night, 40 in the day, and 60 in between those. That's the general rule of thumb if you have nothing to look on. And set up and start listening. I started looking into this. I've always been interested as a ham in emergency communication. So I've been using NVIS from day one, but I've been using it from my house in Fort Collins, which is flat, so it wasn't really challenging. Marty has had some problems with communications in some events he supports in the canyons with repeaters and VHF, UHF. So last fall, I started actually taking my show on the road and going up into the canyons and playing with this. And I'll talk more about antennas here in a minute, but every time that I have gone out, every time, and I bring an ICOM 7300, which has a spectrum display and a waterfall, and I can see a whole chunk of band. I can see if there's people that I can hear or not without having to turn the dial. Every time I've gone out, either on 80, 60, or 40 meters, I can hear people and I can talk to them and they can hear me. And I have found nets, Nebraska Aries net, that I didn't know about by trying 40 meter daytime NVIS. And there was this big, huge spike. And I'm like, oh, what's this? And I rolled over onto it and talked to them. Turns out they're very interested in NVIS and wanted all the details in what I was doing. So it works. But the ionosphere gets a vote. As Mike asked, what does the solar cycle have to do with it? Sometimes there might be a few hours before sunrise where there is no NVIS on a particular day. The next day, it might be very strong. It might go all through the night. So it shouldn't be the only tool in your tool bag, but in some cases, it will get you communication when nothing else will.
I ran into some guys last weekend, today, Saturday, about this time. They're up in Lander, Riverton type area.
Uh-huh.
They're using your server, they're using that Utah server.
Yeah.
Just to know what they're seeing, hearing, and everything as well.
Yep. So the statement was there's some guys up in Lander, Utah using some online Kiwis. Lander, Wyoming. And they're using some Kiwis in Colorado and in Utah to see what's open. That brings up a good point. During some of my experiments with this, there are a bunch of software-defined receivers that are available online, including Kiwis and some others. There's a really good Kiwi receiver online in Broomfield, and he has a good NVIS receive antenna. He has a amplified loop close to the ground. He's one of the stations I test against because I can pull his receiver up online and see it and hear it. And I will transmit from my house in Fort Collins with an NVIS antenna as I watch this. And when 40 meters is open, for instance, he will hear me just fine on 10 watts. When this goes away, I can crank up to 100 and I don't make a blip on his screen. So it's very dramatic and abrupt. After I went up in the canyons by myself a couple times, some other people got involved. Bob, W0BNC, Bart, N0NYY, and a couple other folks. And we went to canyon between Pooter Canyon and Big Thompson. And we were able to talk canyon to canyon and canyon to flatlands. And there's a Aries HF net every Sunday morning, 3.8 something, 3810, 8 o'clock in the morning, 80 meters. And their net control's usually in Pueblo, and they have people all over the state. I have gotten out of bed early enough to go up the Pooter Canyon to Stevens Gulch, set up an NVIS antenna, and work their net. And I've always been able to work their net at 8 in the morning every time I've tried. And because when you get up there away from everything and set up a low horizontal antenna, your noise level is 0. And I have been able to hear stations on the net that net control could not work. And typically during that Aries HF net, there's a station in Pueblo, there's a station in Grand Junction. Bob is usually on in none, and I can work all 3 of those just fine. Grand Junction's 200 miles away. Pueblo's 150 miles away, and I guess none's about 30 miles away. There we go. That net, that 80 meter Aries net, does a thing CYMMN. Can you hear me now? And they made an acronym out of it. And here's Jim K6ET. I wasn't on this net, but we have all these people around. These are all the people on the net. And I can work all these guys NVIS from Stevens Gulch from my vehicle. And during one of the nets I participated in when I was up at Stevens Gulch, somebody was in a park in Arvada, I think, 10 watts QRP with a horizontal antenna, and we worked each other. That was all tough, but with his 10 watts, but we did it. So this can work and does work. Talk now about antennas. What's a good NVIS antenna? And the links get into this better. Well, a really great NVIS antenna is a dipole cut for the band, a quarter wave above the ground. Well, on 80 meters, that's about 60 feet above the ground, 66 feet above the ground, which is kind of tough. It's doable. It's kind of hard if you go out to set up somewhere on your own to get a horizontal 80 meter dipole 66 feet off the ground. It's easier if there's big tall trees in the right place and you can throw some rope over some tree limbs and hoist something up. 40 or 60 meters, you're maybe about 45 feet above the ground. 40 meters, about 33 feet. Now it's starting to get doable. Well, when you look at some of the resources, some of the links I posted, you'll find out that when you come down from that quarter wave height down to like 1/10 of a wavelength or even a little less, down to about 15 feet, you really don't lose a lot of transmit signal. on NVIS. You're not hurting yourself a lot yet. And on receive, you're actually doing better because you're not hearing as much noise off the sides. I've been playing with this a lot over the years at my house, and now beginning last year out in the field. I've done all sorts of different heights and all sorts of different things, and importantly, over different types of ground on different days. Because what works one day won't work the next because of the ionosphere. What works in one location won't work so well the next because of the ground you're over. I have found out myself, in my opinion, personally, based on my lived experience, that 15 feet's a good height to really depend on. Now, I've gone below that, other people have gone below that. Some of my canyon experiments were at 9 feet because I figured out that 9 feet is about the lowest you can safely be where a tall person, unlike me, might be able to touch the wire and get a burn. So I played around with 9 feet for a long time, just for that reason, and that's what I did most of the 80-meter Aries nets on was 9 feet. Bob uses 5 feet, and he gets very good results in on at 5 feet. Bart ends around while I was trying 5 feet at his house in Evans and getting horrible results. Part of that was his wire was on a wood fence that maybe was damp and maybe absorbing RF. He came away from the fence, and I think he got some improvement on that. Some people play around with putting reflecting wires on the ground underneath. From what I haven't really played with that, from what I've read, is if you're up 15 feet or more, that's not as critical. As you get down close to the ground, it becomes more important to have a reflecting screen on the ground to prevent RF loss into the dirt. And the other thing it will do is give you more consistent SWR as dirt conditions change, wet, dry, snow, frozen, thawed. So you'll remove some of that variability. One day, years ago, being bored, I took an 80-meter dipole and a bunch of kitty litter buckets, which are 14 inches tall, and used those as supports, and I set up a 80-meter dipole 14 inches off the ground. And the first thing I saw was the tuning was way off because capacitive coupling into the dirt that close made it resonate much lower. So I had to cut several feet off each end of the antenna to make it resonate, but then it worked. It wasn't a good match. I don't know what the impedance was. It wasn't anywhere near 50 ohms, but I was able to use a tuner and make it work that particular day. And I talked to OJ and Greeley from Fort Collins. Well, the antenna 14 inches off the ground. You'll see some websites where people talk about NVIS antennas 10 inches off the ground being really great. I wouldn't bet my life on it. If you had to set one up down low for some reason, you could, and you could give it a try. Again, my experience, 15 feet. If you can, it's not that hard to get a wire 15 feet in the air out in the woods. If you're in the desert or a big open prairie, Pawnee National Grassland, there's not a lot of trees out there. So if you don't have supports, poles or masts or fiberglass masts or PVC or something, you might have to run something from the top of your car out to a rock or something like that. So do what you can, but dipoles work quite well. Dipoles cut for the bands, so you're talking about 3 different bands or 3 different dipoles, or a dipole with clips or traps so you can work on multiple bands. For my work, I was gearing towards how do I put a bunch of junk in my car and drive out to a canyon and set something up by myself and work all 3 bands without having to run around and clip and unclip things to change bands. So my focus has been on end-fed antennas, and there's end-fed half-wave antennas that Jim used to make and sell before he went to random wires. Those work on multiples, so they'll work 80-40, they won't work 60 without going out and removing a clip in the wire. End-fed random wires of the proper length will work all the bands within a range, so 80, 60, 40, 20, 10, 6 meters. So my focus has been on an end-fed random wire antenna. At my house, that's what I have, 84 feet long at 15 feet with a 33-foot counterpoise coming down and a 9-to-1 balun at the feed point. Why a 33-foot long counterpoise? Because I had a 33-foot piece of wire from a 40 meter vertical. Yeah, so I had one. In the field, I was working with, and what I have set up, I even went and I had to go to the Home Depot in Loveland because Fort Collins didn't have it. I bought some orange THHN wire. I use THHN house wire from Home Depot for everything, all my antennas. But I went to Loveland to get some orange stuff because that's like emergency. You know, that's cool. So my field NVIS antenna is an end-fed, and it is 72 feet long with a 28-foot counterpoise. Why?
What, 100-foot spool?
Yeah. Buy a 100-foot spool of wire, 74 feet or 72 feet is a good NVIS length for 80, 60, 40. That's a good length for an end-fed for 80, 60, 40. If you cut it, what's left over? 28 feet. I also use my Xterra as a counterpoise. And I have a railing on my Xterra. It's an aluminum railing on plastic mounts, and I found out they're isolated. So I took one of the mounting screws out that goes into the roof and replaced it with a stainless steel threaded stud and a cap nut so I can make a ground connection to my roof. Marty had a question.
You're using a tuner with this, right?
Yes, and I started with a manual tuner on purpose and a nano VNA to make it easy to tune up. Because with a manual tuner, I could see what's going on, and I could see how touchy the antenna is, how critical it is, how much bandwidth I have before I have to retune. And I found out on an end-fed random, although you can tune a wire that's less than a quarter wavelength long, that's where it gets finicky. So I went with more than a quarter wave on each of those 3 bands, which is why I'm using the 72-foot wire. On the random wires, you need to stay away from half wavelengths and multiples of half wavelengths because the impedance shoots up through the roof. So you don't want to be near a half wavelength. You don't want to be near a quarter wavelength if you're using a 9-to-1 balun because it's not a good match anymore. That's why 72 feet's good, and it's more than a quarter wavelength even on 80 meters. So that's where that number comes from. Sounds like a long wire, and it is kind of a long wire, until you get out in the open somewhere, like a field, and or the woods or something, and you set it up, and you go, oh, it doesn't seem, you know, I set it up at my house, it seems like it's a pretty long wire. Out in the open, it's not a very long wire to set up. It's like, oh, it's just like from here to there. Okay, no problem. So that's what I'm using. Inverted V's are good. A classic inverted V, the legs come down at like a 90-degree included angle, or shallower. You don't want to be steeper than that. If you're going to do NVIS, spread them out more towards horizontal. You don't have to be perfectly flat top with a dipole. You can let it droop down a little bit. You can take any 2 bands that one's the multiple of the other, like 80 and 40, or 60 and 30, or 40 and 20, and you can put a central mast up. You can have one dipole coming down this way, inverted V, the other coming down this way from it, and you can have the feed points tied together on one coax. And that is also self-guying because your wires, once you get to the end, you have an insulator and then rope from there on out. So it becomes a self-guying structure with one mast. Very easy to set up. A good NVIS antenna if it's on the right bands. And Bob uses one. I've played with them before. Be a good field day antenna too for 2 bands. You don't need a tuner once you trim the legs to the right length. When you're on one band, the other band at that frequency will be an extremely high impedance, so your RF doesn't even try to go that way. It goes into the correct legs, so you don't need a switch at the top or 2 coaxes or a tuner or anything. Joe?
Ham sticks.
Ham sticks. I haven't done this. Some people have. Take 2 ham sticks for like 40 meters or any of these bands. Mount them on a T horizontally from a vertical support off the ground. Did you try that?
No, not yet. I was wondering.
No, Darren. You were doing some.
As NVIS.
Okay, yeah. So that's an option. They'll be a narrower band. The ham sticks, as I understand it, have a tunable tip on the end. So without retuning, you only have a portion of the band, but you could use them horizontally. Again, if you can get them 15 feet, that'd be good, and that shouldn't be hard at all to get a couple ham sticks up at 15 feet.
Now, would you try to angle them or keep them horizontal?
Keep them horizontal, and that reminds me, one question that comes up, if me and Marty are going to work NVIS, well, there's 2 things. First of all, if you're going to work NVIS, you want the person on the other end to have an NVIS antenna as well, especially the closer in you get. If I've got my NVIS antenna in Poudre Canyon and I'm talking to the guy in Grand Junction, it probably doesn't matter because at that further distance, I'm coming down to him or her at an angle, right? So if they had a vertical, it would probably be okay at 200 miles out. But if we're all working together in Larimer County or Larimer and Weld County, everybody needs a horizontal NVIS antenna. Now, if me and Marty are working Fort Collins to Wellington, and my NVIS antenna runs north-south, does his NVIS antenna have to run north-south as well? Nope, because we're shooting up, and we're literally polarized shooting up, but when it hits the ionosphere, it starts turning, and it comes down in what's called elliptical polarization, so it's rotating as it comes down. So we don't have to worry which way our antennas are pointing as long as they're horizontal or semi-horizontal. There's a question about tilt. If you're trying to favor one direction, maybe try to extend that 400-mile range out a little more, but in one direction. You can, instead of being horizontal, you can tilt more towards the direction you want to work and get some improvement in that direction. Roger.
You got some favorite frequencies on those 3 bands?
I do, because I'm an extra. when I'm working with other people that are an extra, and especially with this great propagation we've had lately, we'll pick a frequency in the extra band if we're all extras because we can probably find a spot that's open. So, yes. But otherwise, it's just, you know.
And this is sideband?
Yes, yeah, sideband. Or I'm going to start this year when I start playing again, I'm going to start working some digital data modes like PSK. I love digital data. I hate digital voice on amateur radio. We won't get into that. But digital data modes, the ones that you can actually have a QSO with, like PSK31, Olivia, MT63. Some of these modes are almost eerie in that you can't even hear the signal and you've got text appearing on your screen. So between the process gain you have there and NVIS, I want to combine the two and see what can really be done. After I figured out what worked by going up in the canyons, and I talked about the Aries net, there's a 40-meter net, high noon net. And at least last year, Kevin Utter, N6GN, was net control on Thursdays. And 40 meters is a daytime NVIS frequency or band. And his antenna in Fort Collins happened to be a good NVIS antenna.
Better be, I gave it.
Yeah, but at the height. It's horizontal. It was at in the right range of the height you kind of want to look for. So one of my guinea pigs was Thursdays. I would go out on a Thursday and talk to him on the high noon net from different locations. Once I figured out what works and what works well, I started playing around with how short of a wire can I use, how crappy of a location can I be in, how low to the ground can I use, how low can I turn the power down to see what kind of margins I have, and that was kind of fun. Dick, question?
For a, maybe slightly off topic, but if you're using an in-bed half wave and you're using it more as a sloper, I've seen where some people like to put their matching transformer low to the ground. I've seen some that advocate putting it, at the highest point you're at. Have you seen any difference, or have you tried those two options?
I have not, and I haven't actually done anything with slopers. I've seen Roger use them. The nice thing about an end-fed with the tuner at the ground is you can be sitting right next to the tuner with your radio. And all you have going up is wire, and you throw a rope over the tree. If you put your tuner 50 feet up a tree, you're going to need all that coax coming down. You got to get it up there, and then you run. You did remind me of something I said. I started off with a manual tuner to really see what's going on. Once I figured out what wire I wanted to use and how I wanted to set it up, and vehicle as a ground plane and everything else, I went to an ICOM AH4 auto tuner at the feed point, and then a counterpoise wire coming down to my vehicle and tying into my vehicle as added counterpoise, and then the horizontal wire going out. And with the auto tuner now, I could change bands without even have to mess around retuning. So once I figured out my design and wire links and everything else and how to set it up, I went to an auto tuner at the feed point that's designed to tune a wire antenna. And that's awesome. That thing is great.
Can I talk to you later about the AH4?
Yes.
I won't take
Yep.
time now.
Yep.
So you're using the AH4 with your 72-footer?
Yes. And I've used it with shorter wires too, as part of what I said, what works. Now that I know how to do it, what can I get away with? How short a wire can I go, and other things like that. But really, you'd have a hard time being out in the great outdoors and not have 72 feet to set a wire up in. So that's basically the go-to thing right now.
How much power are you running?
100 watts unless I can really turn it down.
Okay.
But especially for like a statewide net, I'll start off at 100 watts. Marty.
Do you have the chart shows the lengths of wire? Because people hear random wire. It's not a random wire.
Right.
It has to be
Yeah.
Everything but.
Yes.
everything but random.
Yes.
So I'm trying to find it.
I got it right here.
You have it?
Yeah.
I wonder if
It's Jim or somebody that's doing this.
if you send it to me, I'll forward it to Jim.
Yeah. So the question was, do I have the chart for random wire lengths? Marty is correct. The term random wire is not actually random. There are good lengths and bad lengths. The idea being, and again I had mentioned this, that you want to stay away from half wavelengths and multiples of half wavelengths. like 1 wavelength, 1.5, 2 wavelengths. You want to stay away from all those, and you want to stay away from quarter wavelengths if you're using a matching transformer that changes impedance, because then that'll change that quarter wave into something useless. So if you want to work a bunch of bands, like 40 through 10 or 80 through 10, 160 through 10, there are only certain lengths you can get away with that meet all that criteria of you're not near a quarter wavelength or a half wavelength or a multiple of on any band. For our purposes, NVIS 80, 60, 40, if those are all the bands you worry about, you have a lot more leeway and a lot more options. But I'm using 72 feet, which is in this range, which gives me 80 on a anyway. But that's just what I'm using. But just keep in mind, if you're only worried about 80, 60, and 40 meters, there's more options. And essentially, if you want to cut and measure and use your nano VNA, you put your antenna up as you intend, and if you can find a length that's kind of gives you around sort of 200 ohms on each band, you use a 4-to-1 transformer at the feed point, you've got 50 ohms. I went with trying to get kind of sort of around 450 ohms at the feed point. And I have a 9-to-1 balun, gives me about 50 ohms. I say about, you still need a tuner, especially if you're going to work all the bands, you're going to need a tuner. But that gets you kind of in the ballpark, so you don't have as much loss on the coax, and the tuner doesn't have to work as hard, and you get more bandwidth. Joe?
The minimum coax length, is that for radio use?
This chart, which I've never seen before today, says minimum coax length.
It's using the braid.
Yes, it suggests to me it's using the braid of the coax as the counterpoise.
That's kind of what I thought.
I use a separate counterpoise wire coming down at an angle, and the coax coming down not parallel to that, but away from that.
And are you doing
To
a choke?
get less RF coming down the coax into my shack. And by doing that, I don't have to use a choke on my coax, but I'm not terribly worried about a little RF in the shack. If there was a problem, I'd use a RF choke. In addition to the 9-to-1 balun, I'd use a 1-to-1 choke after that on the coax to keep RF off the coax. If you're not using any kind of counterpoise, it will use your coax shield. It will use your coax shield as a counterpoise if you don't use a separate counterpoise.
Yeah, this list is my list that I use for my 9-to-1 baluns that I make for people. That this is without a counterpoise. If you use a counterpoise, you don't have to worry about the minimum coax length.
I was curious about the 160. On the 160, they're showing 130 feet. I don't even have 15.
Yeah.
You know,
Yeah.
so that's why I was curious. So,
Yeah.
And obviously, my counterpoise is 130 feet.
Right.
Now, granted, I'm not on 160. I was tuning to it.
Yeah.
When I was down at 54 feet, when I went to 80 or 84, whatever it is, I can't even tune 160. But
Yeah.
I finally got out on 160. I was all excited. Marty said that he got to 160. I said, "Oh, get out of here."
Yeah.
So then I tried to tune it, and sure as hell, it
Yep.
did it.
Can you
Added another
pull
20
up
feet
that
and lost it all.
PDF book or that report, that Whitlivet report? One of those links, that wasn't a link, but
This one?
yeah, you can go to the top of that. By the way, those drawings I showed you, the skip drawing and the NVIS drawing, I stole those out of this report. But this was attached to the email I sent to members. So if you didn't get it, you don't have it. I don't know if we're going to put that on the website, but Ben Whitlivet is the primary author here, Whitlivet. He was with University of Twente in the Netherlands, and they're big RF folks out there at that university. But in the Wikipedia article that I did give you a link to, down in all of their footnotes, all of their links to their article, or their sources for their article, there is an original link to this, which is dead, and then they have a link to the Internet Archive, which is good, which gives you this report. And this is like 16 pages long. This report, they went out, and in the past they used helicopters with receivers on them and flew over the NVIS antennas. I don't know if they did that in this, but they set up transmitters and receivers with NVIS and direction finding, angle finding receiver antennas. And they did a bunch of stuff to measure the height of the antenna versus its effectiveness, height above ground, below a quarter wavelength. So getting down into more practical heights above the ground. And they made some nice graphs of when you, at what point you really start to lose, you really start to hurt yourself on transmit. And they also concluded that the best transmit height is different than the best receive height. If you're only worried about receive, you can go lower for your best performance because it's noise versus signal. So to anyone that got my email, this report's in there, and I think we'll get it on the website.
It's already there.
All right, it's on the website if you didn't get the email. I noticed this morning at the top of this thing there was there were some links to other reports that I haven't even looked at, but this same guy did another report on NVIS communication for humanitarian relief, and I think that will be an interesting, because that's a deploy to the field kind of thing. So I haven't even looked at that report. I think that will be useful and interesting. But for the people that really wanted to get into the physics of stuff and the math, this report will make you happy. Have fun with that. Any other questions? Marty, after I started testing this last fall, Marty had prompted Marty to go out and get his general so he can do NVIS. He is interested in using NVIS for communication support of some canyon events this year. He's doing a dry run, trial, field day test kind of thing, March 25th, which is a Saturday. Because of the start time of his event, the start time of his test is 5 a.m. local time. He's going to be...
Changed it to 6.
6, okay, all right.
Bob and I used
Yeah, so...
not much difference.
Yeah, so I believe you'll be at your property near Wellington, and you want some hams to come out to Wellington, and you're going to have some brisket or something maybe, or some sort of breakfast
We should probably have
stuff.
pork, but
Yeah, some kind of
have
pork or something.
beef.
Yeah, okay. So I'm going to stay home if the weather sucks, but if the weather doesn't suck, I'm going to either be near Ted's place, which is the start-finish for one of the events, or I'll be up near Stevens Gulch or somewhere up in the canyon, depending on how many more people join in and how many spots we can get covered. But Marty wanted to test this and maybe get some more people to come in that have their general that want to either have done this already or want to try it out, to either be out at his place or be up a canyon somewhere. And we'll see who we can talk to, and we think, but by the time, at least for the March 25th test and then the May event, we're thinking we only need 80 and 60 because we don't think we'll go long enough into the day to be 40 meters. So you definitely will need to do 80 meters at 6 a.m. But if you want to try it, if you already had some NVIS experience or you want to get some, March 25th. Marty has an email list going now, but if you're here physically, you can get it added onto it. And if you're on the remote, Marty's website is kc0qok, or his email, kc0qok at gmail.com. So just email him if you are visiting us over Zoom and you want to get on that list and play. Any other questions?
We're going to have several different setups out there too.
Yeah.
I'm going to have 3 different antennas with each with its own radio setup. I mean, Marty's going to have a couple different setups for like mobile NVIS.
Yeah.
We're going to have quite a variety of things going on.
Yeah, so if you even just want to come out and look to see, or if you're still a tech, then you're thinking about getting your general license. If you want to just go out to Marty's and look and see how are people setting this stuff up, that'd be a good opportunity. Or if you want to see it in action. So.
Bob's got an idea.
All right, I think that's it. Thank you.
This presentation was brought to you by the Northern Colorado Amateur Radio Club. For more information, visit our website, ncarc.net. Thanks for watching, and don't forget to like and subscribe.